effectively there is a movement into environmental protection, social equity, social institutions, a dematerialisation. So there is a move to a global society that is less reliant on material developments, material gain, and to high levels of economic growth. The B2 scenario is effectively moving further along the tree-hugging route, increased concern for environmental social sustainability, a trend much more localism, local self-reliance, stronger communities who are taking responsibility for themselves with a commitment of sustainability. And effectively, there's still difficulty designing and implementing global protection, but there's a much greater local commitment to actually doing things. Overall, the argument is that because there's this more local sort of regional structure, international institutions will become less important. There will be a reduction in energy R&D, which means that there will be a shift to more local sourcing of energy rather than making energy, the ability to sort of get energy from anywhere and transport it to anywhere. And there'll be great variety. There'll still be hydrocarbon based, we'll still have quite significant changes in variation rather between different systems. There'll still be a lot of hydrocarbons being used. So the idea is you take these scenarios over the period of sort of the next 100 years or to the end of the century, and you translate that thinking into fossil fuel use and emissions. So the amount of fossil fuels to be used and the quality with which they are used in terms of the impact of them on global greening. So for instance, some will have the same amount of coal being used, but much greater removal of carbon dioxide at source. Some will have similar amounts of renewable energy, but the costs may be slightly different depending on the scenario, the economic scenario you're putting in. Population growth is pretty well modelled, so we can make estimates on those criteria for population growth. And economic models, which as we all know are fantastic and always right, mathematical economic models can be applied as well. So the effect effectively, sorry that's bad, so the effect is to produce a scenario translated into greenhouse gas use, and from that to predict the likely impact therefore on climate. And these SRES scenarios were used for the third assessment report and also are the basis for the runs of the models that you see in the fourth assessment report, chapter 8, which we'll go through in detail later on in another planet. So if we look at those sort of scenarios, what are they saying for population growth? As you can see, the A1 and B1 have peaking population growth around 2050, falling off by the end of the century, and are the low end of the spectrum. That's because B1, social responsibility, sustainability, it's recognised that you can't really, we can't have this number of people. A1 is, I think, predicated on the value that once you've got all the countries developed rapidly up to about here, then what happens in developed countries is that population growth slows, and therefore the fertility rates slow and will eventually fall off. So they're both, A1 and B1 are both predicated on a world global population of only about 9 billion by about 2050, and then declining. Now that's totally unrealistic, I think, if you look at where we're at. Well, we're at 7 billion at the moment, aren't we? Predicted to 10, I don't know the exact figures. But that's pretty sort of optimistic in terms of population. B2 is continued growth, but slowing off, but still growing. And A2, which is the middle one, that again, based on those assumptions, we have prediction going right up to over 15 billion by 2100, and effectively no real change in growth rates. If you look at separate population predictions and you look at some OECD data and other models, you can see the range is huge. The range of possible population projections is huge. And, you know, we go from, let's take the A2, 15 billion to 6, just over 6 by 2100, depending on which projection and population model you accept. So you can see how these different scenarios are already pulling out different futures in terms of greenhouse gas forcing. Nice complicated diagram here, but it's actually quite straightforward. This is energy use, and it is the three basic forms of greenhouse gas energy users, or non-greenhouse gas ones. So we have coal down one side, we have oil and gas down one side, and we have renewables, nuclear down the other. And what these marks suggest is the trajectory. This is the trajectory, global trajectory from 1850, which is largely, obviously, coal coming through, suddenly hitting oil just after 1900, and moving up here to 1990, where we see a reduction in coal and an increase in oil. So we can see this shift between coal and oil taking place throughout the 20th century. What happens then? So one scenario will have us go, B2 for instance, will have us going right down here. B1 is the green, going in this direction, and the other one, where's the A? A1, C and A2 have us somewhere going up in these directions around here. We're not too sure which way they'll go. But again, you can see that there's a huge difference in the nature of the energy use that is predicted according to these models and these scenarios through time. And if you look at the difference in terms of greenhouse gas forming between one that's over here and even one that's over here, and any that's over here is huge. And so again, our projections into the future based on the SRES models seem to follow any of these particular, they are stretching the different options. CO2 as a sort of synthesis of those. These are all the possible data projections depending on who you want to follow. A1 is up here. This is carbon dioxide emissions probably in amounts rather than in global. They're not in concentrations. But you can see A1 and A2 are up here. B1 is down here, sort of, all going on a trajectory up to 2050, which is growing and growing. B2 possibly levelling out and being the lowest of those, B1 possibly getting as low as here. But you can see the difference between there is, what? Fourfold in terms of CO2 emissions. So whichever scenario you follow, you have huge difference in terms of the actual output, in terms of what the greenhouse gas forcing is going to be. And so you can see that, again, all these projections, for the same model, you can put these projections in the same model, different projections, they will all give very, very different answers as to what the climate is going to be, depending on where those emissions go. And also a difficult one is land use change, which is effectively a combination of a whole range of things in terms of its impact on global carbon emissions. The general effect is, again, that there's likely to be some early peak and then the impacts will go down as land use changes and the agricultural and urban changes actually take place. Again, they're very, very spread. They're very, very effective, and they will potentially have a negative effect of actually, with the land use change, can reduce the impact, relative impact of CO2. So that's the SRES range and the SRES family, and what you'll find is that the models, whoever's model it is, tend to run according to A1, B, A2 and B1. A2 is the high equivalent of business as usual, everything flies out the window and we still use lots of greenhouse gases, we still procreate quite heavily, we still have an improved longevity in developed countries, and we do nothing to potentially control our use of greenhouse gas, very limited amounts of control of impacts on climate. So our A2 is our high emission scenario. A1B is the medium one, and this is the sort of one that tends to be the middle ground, Liberal Democrat sort of approach, you know, the Goldilocks approach, not too hot, not too cold. And in a way, if you ask anybody, that's what they expect to happen. You know, that's the British way of looking at things. That you know, it won't be too bad, it won't be too good, but you know, it'll be all right. You know, we'll still get a cup of tea, so it'll be fine. B1 is the low sort of emission, which suggests that, you know, everybody suddenly goes green, lives in a yurt, and starts burning dung. I mean, it's that sort of, it's not quite as severe as that, but it's an assumption that we get hold of the core forcing mechanisms of greenhouse gas emissions. It's still not it still doesn't return us to a sort of pre-Lapsarian, pre-industrial world. You know, it's still way away from that. This is just reducing the impact and reducing the actual direction of change. So when you look through all the IPCC report related material and you look at projections for the future, you will usually see these three scenarios being used and these three projections being made as the worst, best, medium case scenario. So most diagrams and graphs you'll see will follow those sorts of patterns. And the IPCC, sort of, because it's a sort of centralising body, and it's responsible for, it has been largely responsible for helping develop these scenarios, then most modelers see the modelling into the future as directed into IPCC outcomes. So HADSEM, people at Hadley Centre and NCAR, everywhere, will use those as a basis for running their models, because they won't use different emission scenarios, because if you have the same emission scenarios for different models, at least something is constant. So you can compare NCAR model with Hadley model for the same emission scenario.